Hello everyone, my name is Kathan and today we will be discussing the problem sum of three values from the sorting and searching problems of the CSES problem set. Let's begin. Let me read out the question for you. You are given an array of n integers and your task is to find the three values at distinct positions whose sum is x. The first input line has two integers n and x, n representing the size of array and x representing the target sum. The second line has n integers a1, a2, so on till an, the array values, and the output you have to print three integers, the positions, distinct positions. If there are several solutions, you may print any one of them, but if you are not able to find a triplet whose sum is equal to target sum x, then print impossible. Now this question is a direct extension of the sum of two values question in this section, so I highly recommend that you have watched the video of sum of two values. If you have not watched the video, you should be able to solve that question on your own, right? Because I'm gonna use a lot of ideas from that video or maybe just the question, right? So yeah, with that thing clear, let's look at the example test case here. So array size is 4 and the target sum is 8. So you have to output me positions such that the sum of values at these three positions will become 8. So here you can see the output is 1, 3 and 4 because if you add the elements at position 1, 3 and 4, it gives the target sum 8. And that's the question. You are given an array and you have to find out three distinct positions whose sum is actually equal to target sum. You have to find a triplet whose sum is equal to x. If such triplet is not existing, you print impossible, right? So that's the question. Let's go into the iPad and try to understand this question a bit more. First things first, let's talk about constraints here. So what is n? N was as high as 5000. So if you observe this, this is a relatively less constraint. So I hope you didn't miss that because there was a chance you might have missed it. So n can be only as high as 5 into 10 power 3. What does it say? Even if you implement the order of n square solution, it's gonna consume what? You multiply n both the number of times, so it will be 2 times. So 25 into 10 power 6. This is what? This is actually equal to 2.5 into 10 power 7. Right? It is actually less than 10 power 8. So you can implement the order of n square solution, right? Because in 1 second, which is the time limit of this question, you can do, like you can say, at most 10 power 8 operations. So even if you actually employ order of n square solution, it's gonna work. So that's interesting, right? So you present me anything better than you can say n square. So n square, n log n cube is definitely not gonna work. You can clearly see it's gonna exceed 10 power 8. But what about n square log n? Can you do n square log n? Let's see. So to this factor, like this 2.5 into 10 power 7, you will have to append log 5 into 10 power 7. 10 power 3. 10 power 3. Now even if you ignore this 5, what is log 10 power 3? I guess you already know, we have discussed a lot of times. This is actually 2 power 10, right? So log 2 power 10. So it will turn out to be 10. So this entire thing will come out to be 10. So this will be what? 2.5 into 10 power 8. Right? So this is tricky. You are at the borderline. So you should not prefer such solutions, okay? So in my experience, this may work or may not work. So n square log n, maybe you stay put, but yeah, n square or anything better than that works. The example test case, I guess we've already seen, but I'll just quickly look at it once more. So n was 4 and the target sum, let me call it as x, was 8 and the elements that were given were 2, 7, 5, 1. So what we are supposed to find is we have to split the position such that sum of those three values give me the target sum 8. Right, so we have to find here a triplet. That is very important. We have to find a triplet. Let's just call them AI plus AJ plus AK is actually equal to X. So we have to find triplet whose sum is equal to X, and we don't have to actually output the triplet, but you have to output the position. That is IJ and K, which is actually 1 based. That is fine. Now here, do you see some elements whose sum is equal to 8? Of course, right? So 2 plus 5 plus 1 gives 8. So you have to output what? 1, 3 and 4. Fine. So I guess they are not worried about the positions. Like you can print the positions in any order as well. So that's one thing. Okay. So I mean that's the question. Now how do you approach this question then? Now, the first idea that can come to your mind is what is the brute force, right? You should always start from brute force and maybe try to optimize it on it, right? So what is the brute force here, guys? So what we are supposed to do here? We want to find triplets, right? So if I can solve this problem, finding a triplet such that whose sum is equal to x, the index are not very hard to find, right? I can always store an index with an element. So if I can find a triplet, my job is done. Now how do you find a triplet? We just enumerate all the possible triplet in brute force, like all the possible triplets. How many triplets are there? How do you enumerate all the triplets? It's simple. What you do is you run a loop. You actually run a nested loop, right? So you will make I go from 1 to n minus 2. Then you will go j run from I plus 1 till n minus 1, and you will run k from j plus 1 till n. So it is like if you have elements like a1, a2, a3, so on till an, what you'll do is you'll fix a1, right? You'll fix a1, you'll try to find all the possible pairs. So this loop I guess you're already familiar with, right? So finding all the possible pairs. Then you fix a2, then you find all the possible pairs from a3 till an. You fix a3 and then find all the possible pairs from a4 till an. I go till n minus 2 because the last possible triplet will be formed by n minus 2, n minus 1 and n. Right, so that's why. So you can write a nested loop here and find all the possible triplets, and whenever you have a triplet here, you can simply check whether ai plus aj plus ak is actually equal to x. If it is, then yeah, you got our answer, right? So yeah, this nested loop is there to enumerate all the possible triplets. But what is the time complexity here, guys? Of course, there are 3 nested loops. Each one of them has a time complexity of n, order of n, right? So the time complexity turns to order of n cube. So you cannot implement the solution. But so yeah, so order of n cube solution is not going to work. Okay, fine. But can we get an idea here? Brute force. From brute force, can you get an idea to optimize this? That's an interesting thing, right? Now, what are you effectively doing in this brute force? If you observe, we are fixing, right? We are fixing a value of ai, right? So we want to find ai, aj, and ak. In the brute force, what we effectively do is we fix the value of ai. We fix the value of ai, and try to find a pair. Try to find a pair whose sum is equal to x minus ai. Don't you actually do that, right? So what I'm saying is, guys, if you had, let's say, sum equals to 10 to be found, you are looking for triplets ai, aj, and ak, right? So what you can say the brute force does is it fixes ai, right? So for all the I belongs to 1 till n minus 2, right? So because the last triplet will be formed for I equals to n minus 2, what you do is effectively you attempt to find the pairs, important word, pairs, such that aj plus ak is equal to what? From the target sum you remove ai, right? So this, so all that matters is for every value of ai from 1 to n, you are looking for a pair whose sum is equal to some value. Does this ring a bell? Like isn't this problem same as the two sum problem or the sum of two values, right? See, in the brute force, what we are effectively doing is we are going from I equals to 1 to n minus 2. In other words, we are fixing the value of ai, right? For all the I belongs to 1 till n minus 2, and we are aiming to find a pair, important word, pair whose sum is equal to remaining value after I subtract ai, x minus ai, right? So the problem is for each value of I, you find me a pair whose sum is equal to some value, let's say some target t. Now this problem is already solved, right? And how do you solve two sum problem, guys? Now I highly recommend you that you watch that video of sum of two values. Otherwise, anyway, I'll try my best to summarize what I have discussed in that video. Okay. Now to solve the two sum problem, here if we concretize stuff a bit, we are going from I equals to 1 till n minus 2. In other words, we have our array like this, and at a time we fix some value of I, right? We fix some value of I, that is we have ai fixed, and then in the remaining portion we attempt to find our aj and ak, right? Such that aj plus ak yields the target sum t. And what is this t? This t is actually equal to x minus ai, right? The remaining sum. So x is the, you can say, the triplet sum, and this t is the required pair sum in for each value of I, right? So this is what we have to effectively do. Now one approach is you use a hash map, right? So you already know you can use a hash map. You can just do a linear traversal of this search space, and what you can do is you can store the indices of the elements, right? So you can store the indices of the elements, and let's say you are going through the remaining part. For example, j equals to I plus 1 till n. Now what we will see is in the map, if mp of t minus a of j has already occurred, right? So it already exists. Then you found a triplet. Why? Because if mp of t minus aj has occurred, and currently you are at aj, now you have found the target sum t, right? So then the triplet is found. So yeah, this is the hash map based approach. And what is the time complexity of this one? So this actually ran for what? N log n, right? Because n log n meaning whatever the search space is, log n. Why? Because for all the map operations, insertion, deletion, updation, find are gonna take log n. So it's gonna consume n log n. But you know that for each value of I we have to do this, right? For each value of I we are looking for a pair whose sum is x, and for that one sub problem can be solved in order of n log n. Why? This is how, right? You go through the elements one by one and you just check if t minus aj has occurred. If t minus aj has occurred, you have aj, you just add them, so you have got t. If you have got t, it means you have got the triplet. Fine. So this is gonna consume what? How much time is it gonna consume? So for I, there are, you can say I goes from 1 to n minus 1, 1 to n minus 2, order of n, and for each sub problem, you have to do a linear traversal and map operation, so n log n. So this is gonna cost you n square log n. So you better stay away from this solution. It might give you a TLE. If this is not the case, then what else do you know? You know that if you fix this value of I, right? Now in this portion, you are attempting to find aj plus ak such that aj plus ak is equal to t, which is equal to x minus ai. Now the optimal approach to the two-sum problem was arrived because if we sort the array, that is, if the search space is sorted, we can actually find aj and ak if they exist in order of n time, right? How? We simply initialized two pointers. First at the start and one at the end, right? And if the sum was currently greater than t, we move one step back, so k minus minus. If sum was less than, we increment one step, j plus plus. The reason being, if aj plus ak at a given time turned out to be greater than t, there is no point in comparing this k with aj plus 1 till k. Why? Because these values are anyway greater than aj, right? Similarly, if aj plus ak turned out to be less than t, there is no point in checking this aj from the value aj to the values from ak minus 1 till aj plus 1, because any which way all of them are less than ak, right? So if sum is found, eventually if you can say the target sum exists, you will find it. So this you can actually achieve it in order of n, right? So each sub problem can be solved in order of n being the search space. So this search space, right? So every time the search space here is order of n. This relies on the fact that array is sorted, so that is fine, right? So initially we can sort the array. Initially it will consume n log n time, and afterwards for each sub problem, how many sub problems are there? N. For each sub problem, we are going to consume order of n time. So this can be solved. So in order of n square, right? So n log n for sorting the array, and then for each sub problem, we consume order of n. So yeah, this will be a good approach then, right? So this is an optimal approach here then, because it yields order of n square time. And what is the space? It also doesn't consume any space. So it will be simply the optimal solution for this problem. So I found the video a bit rushed. I highly suggest that you watch the two-sum video or the sum of two values video, because there I have discussed this question in complete detail. I even discussed why do we have to do sorting and why the two-pointer approach works by tracing out all the order of n square pairs and showing you how many comparisons are done and all. So that was a very interesting video. I highly recommend that you watch it. And yeah, I mean, that's the classical three-sum problem. It has a pattern which is used a lot of places. And one interesting fact about this problem, the optimal solution till 2014, if I'm not wrong, was order of n square. So we all thought that we cannot do better than order of n square. But I guess in 2014 there was a research paper which solved this problem in better than n square. Of course not in order of n, but somewhere between n and order of n square. So that's one interesting fact about this problem. And If you found the explanation till now helpful, please comment understood in the comment section of the video, and let's move on to the coding part and wrap up this video. Okay guys, let's look at the code. First things first, I'm taking n and x as input, n being the size of array and x being the target sum we are after. Then I'm creating a vector of pair of int. So VII here is a vector of pair of int, and along with all the values, I'm also storing its position. Why? Because after sorting, I also want to maintain maintain a way to find the positions, right? And like the correct position of the value. Then I sort the array. So this all is again a type def I've defined. So n dot begin and n dot end. And then what I do is I fix the value of a, right? So I goes from 0 to here you can say n minus 3, right? So in other words 1 to n minus 2, one the same thing. Then I'm looking for pairs whose target sum is x minus ai, right? So first is the actual value, right? And then the problem is find jk such that area of j plus area of k is equal to x, which is actually equal to sorry it is equal to x minus area of I, right? So I initialize j equals to I plus 1, k equals to n minus 1, and then this is a classical two sum loop, right? So what I do is if the current sum, that is area of j plus area of k, is greater than target sum, I decrement it, right? Why? Because if aj plus ak is giving you sum greater than t, there is no point in taking this k with the values from j plus 1 till k, right? So that's why k minus 1. Similarly, if the sum is less than target sum, we increment j. And then if these two are not the case, then we have found the target sum. We have found aj and ak such that whose sum is equal to the current sum that we are after. And then we can put all the positions, right? So area of I dot second is actually the correct position of area of I, and area of j dot second is the correct position of j, and so on, right? So yeah, and then we can return. But if we have gone through this entire loop and we have still not find the triplet, we can just print impossible. So what is the time complexity, guys? So this consumed n log n, and this entire loop, so this is order of n, and internally this is just order of n, so order of n square. So time complexity is order of n square, and we are not using any extra space, so order of n. You might argue that I'm storing the indices, so yeah, maybe it's debatable. You can tell the extra space is order of n, but yeah, that's the code, right? So I hope you got something out of this video. If you did, please give it a thumbs up, and I'll see you in the next one.